So, in this chapter of electromagnetic induction, the most important thing is that we have to know with the change in magnetic field, there is a creation of current, and with the change in electric field, there is a creation of magnetic field. So, one is related to magnetism, the other is related to current or electric field. Sorry, let me write this in a proper way. This is electric field. So this is the basic backbone of this chapter, electric field, F-I-E-L-D. So now this is due to induction, electromagnetic. This is electro is current and magnetism is magnetism. Okay, now induction is creation of something without the actual contact. That is, you're inducing something. You are inducing a property without actual coming in contact, without contact. So these are some of the basic things that we will be discussing in this particular chapter. And the first point that we will be discussing is your magnetic flux. Magnetic flux that we should know. Now, in this chapter, magnetic flux are the magnetic field line that passes through a particular area. Say, suppose this is a magnet. This is north and this is south. So, magnetic field lines will go somewhere over here because magnets always exist in dipoles. So, if you keep a surface over here, the total magnetic field lines that passes through this particular surface is known as magnetic flux. And magnetic flux for us was given by the magnetic field into area A, which is nothing but the dot product of the magnetic field line in the area vector, perpendicular area vector, or we can say surface vector. This is cos theta. So this is magnetic flux. So now, after we have understood that due to the change in magnetic field, there is a current that has been produced. So this was first established by Michael Faraday, and this is known as Faraday's law of induction. Faraday's law of induction. Law of induction. So let's have a look as to what Faraday's laws of induction tells us. So before Faraday's law of induction, we have an idea that change in magnetic field induces a certain amount of current. So this particular law was stated by Faraday as the magnitude of the induced EMF. The magnitude of the induced EMF. Induced EMF in a circuit is equal to the time rate of change, of magnetic flux through the circuit. Now let's understand this physically. Say suppose you have a magnet which is emitting your magnetic field. This is a magnetic field B. Say. So now flux is given as magnetic field into area. So if you want to change the flux, either you will change the magnetic field or you will change the area. So in a way, if say suppose this is your wire, so if I move this wire to and fro, that is I am changing the area, that is the flux at which it is passing by, it is changing the area. If I'm moving this up and down, we can see that there's a change in magnetic field. The magnetic field over here is different from the magnetic field which is over here. So if you move this object, there is a change in magnetic field with respect to time. With respect to time, as t equals to 0, I have my magnetic field to be something else. Since this is to be b naught. At time t equals to t1, I have my magnetic field to be something b1. So there's a change in magnetic field with respect to change in time. And if this particular situation occurs according to Faraday, then an EMF is induced. That is a voltage, an electromotive force, that is known as EMF. A induced EMF is generated in your electric circuit, and if you join the EMF with a wire, so if this is joined, then what we'll see is there is a flow of current. There is a flow of current, and that EMF is nothing but the change in flux. The change in flux with respect to the change in time dt. So this is what we know. And if you look at the total expression, so if this is my one wire, if I take a numerous number of turns of wire, what I will see is E is actually given as minus n, that is the number of rounds in the wire, upon d phi dt. So this is the total EMF, this is the total induced EMF that has been generated. And this is known as Faraday's law of induction.